On Canvas, I've posted a summary of the reactions from chapter 19. So I've broken it down into things that are related to one another. So acetals, imines, and enamines can all be formed from aldehydes or ketones using these different reaction conditions. So I showed an example of starting out with a ketone. If we treat it with acid and excess alcohol, as well as minus H2O, we can form an acetal. Now you can also use, in the place of excess alcohol, you can also use diols. Okay, with diols, both of the alcohol groups are capable of reacting. So you actually end up forming what's called a cyclic acetal product. We can also form imines, and imines are going to come from primary amines. And we can form enamines, which will come from secondary amines. Now, all three of these, when treated with H3O+, will turn back into the original ketone. So we can actually use these as protecting groups. Now we learned two different ways to remove carbonyls from aldehydes or ketones. We can either use the Wolff-Kishner reduction, which involves taking an aldehyde or ketone, turning it into an amine using hydrazine, and then using KOH or NaOH as well as water, and that will get rid of the imine and replace it with H's. Or you can use desulfurization. And in this case, you would take your aldehyde or ketone and turn it into a thioacetal, then treat it with radium nickel. So either of these reactions is a great way to get rid of a carbonyl. We also went over the reduction of aldehydes or ketones. Again, this was just a review from the alcohols chapter, but we can take an aldehyde or ketone and treat it with LAH or sodium borohydride, and it'll reduce down to an alcohol. We talked about several different carbon-carbon bond forming reactions, including using Grignards with aldehydes or ketones to make alcohols, as well as a new carbon-carbon bond. We learned about cyanohydrin formation, and that's going to involve potassium cyanide as well as HCN, and it'll create the cyanohydrin, which includes an alcohol group as well as a cyano group. Then we also went over the Wittig reaction, and I've just kind of put a summary of the different types of products that can come from the Wittig reaction. However, just as a reminder, we will be forming products that do not have the E or Z configuration, so you don't need to worry about being able to predict one versus the other. And lastly, we talked about a new carbon-carbon bond breaking reaction, the Baeyer-Villiger oxidation. So with this, you can start with a ketone, treat it with a peroxy acid, and it's actually going to create an ester. And this is the migratory aptitude of all of the different groups attached. The H, whenever the H is involved, so whenever we have an aldehyde, it'll turn an aldehyde directly into a carboxylic acid. So you can go ahead and print this out and use it with you as you're doing your homework.